Hello, I'm William, the creator of Texture Array Essentials, and in this video I'll teach you how this asset will speed up your workflow with texture arrays, providing an easy way to use them in many different situations. TAE is a tool to easily create and modify texture arrays, whether that be through simple menus or through custom GUI and shaders of your own. Creating your own texture array is easy. All you have to do is open the Create Array window through the toolbar or context menu and assign the textures and settings to your liking. In this window you can assign your textures, set the array settings, and view the details of the output. Adding textures is as easy as dragging them into the window or assigning them directly through the texture section. If a texture has any errors or is not the same resolution of the array, there will be a prompt where you can easily decide what happens with that texture. The array settings includes many options to determine what happens with the array. It includes whether the array is compressed, if bitmaps are transferred from the textures, and other general settings for the array. It also includes a resize texture setting, which allows you to decide the final output resolution of the array. Enabling the setting will resize all the input textures to the desired resolution with the set filter mode. In the final output section, you can find details of the array with its resolution, depth, and format, as well as assigning a file name for the asset. Now it's as simple as clicking the Create Array button. The array will be created in the current folder in the project window. Configuring an array is just as easy as creating one. You can open the Configure Array window through the toolbar or context menu to view or modify a texture array. Once you have assigned your array by dragging it into the window or assigning it through the field, the interface is the same as the Create Array window with a few differences. Here you can assign new textures to your array and update them individually or change the settings of the array. If you ever want to reset your configuration back to the original array, you can click the button labelled Restore Array Textures and Settings to restore the original textures and settings. Once you have added or removed textures, or just changed the settings, you can recreate the array by clicking the Recreate Array button and it will overwrite the assigned array with your new configuration. You can also save textures from the texture array through the Configure Array window. To save a texture, all you have to do is click the Save Texture button on any texture and choose its location. Now that you know how to create and configure an array, you probably want to know how to use it in your own material. Creating your own material to support texture arrays is easy, and I'll take you through the steps of making the material, adding a shader, and creating a custom GUI that supports assigning textures directly to an array. In this example, I will create a material using two grass and dirt textures being blended by a noise function. This is only one example of using these features, however, and once you know how to use them, it can be blended to any material you like with as many textures as you like. Here, I will create a new folder for this example that will hold the material, textures, GUI script, and the shader. Creating a shader is no different from creating a regular one, and in this example, as I am using URP, I'll create a URP lit graph, but it works the same in the built-in render pipeline and HDRP. When creating the material, don't forget to assign your shader to the material. For a texture array, we will need two variables. One for the texture array itself, and another integer value that determines the location of each texture in the array. This second variable is used to differentiate the index of a texture assigned in the inspector and where its location is in the array. This can also be used for other functions, such as detecting if a texture is assigned in the inspector, or getting a texture from an array with its index shown in the inspector. These functions are all pre-made subgraphs that you can easily use yourself. If you wish to use these functions in a written shader, you can find the scripts in the Texture Array Essentials folder in Shaders HLSL. Once you have created your variables, you can sample a texture in the array using the Sample Array at Constant Index function and inputting both your variables, your UVs, and the index of the texture you want to retrieve. In this function, you can also assign the unassigned color, which will be output when there is no texture at this index. If you wish to manually check if a texture is assigned at an index, you can use the Array Texture Exists node to do another function instead. In this example, as I will be using two textures, I will create two of these nodes and assign the indexes 0 and 1 respectively. Since I am also going to use a noise function to separate the two, I will label them by a simple noise function, but you can use the texture output however you like. Once we have the final output, I will assign it to the base color so that we can see the output in the scene. Creating a sphere to view the material, you can see that it shows up as white, as we do not have any textures assigned. For that, we will need to create our own GUI to assign them. If you have not created a custom GUI before, this may be daunting, but don't worry as I will walk you through everything you need to know. Here, I will create a new script called Custom GUI Example that will inherit from the Shader GUI class as I am using a shader graph. You can find the details of the Shader GUI class in the Unity documentation through the link in the description if you wish to learn more. Make sure to include the Unity editor as it is required for the editor functions, and remember to wrap it in a if Unity editor so it only executes in the editor, or else it will produce errors when building your application. Also include texturearrays.gui utilities for all the GUI functions to handle the texture array. To draw GUI to the inspector, we will override the onGUI function. This will execute every update to the GUI and allow us to insert our own fields and functions. If you wish to keep the default GUI and not create one of your own, you can keep the base.onGUI function, but remember to disable the show in inspector or exposed fields for the array variables in your shader to ensure that they do not show up in the inspector. For this example, I will be removing the default GUI as I only need to draw the array textures. To use the textures in a texture array, we will be using the texture array GUI drawer class. This class handles assigning textures to the array at changing indexes depending on how many textures are set in the inspector, as well as handles the texture array file. To use it, we must first create its object that must be made on the first call of the GUI. Since Shader GUI does not have an onEnable function, I will create one of my own using a boolean to check if it's the first call. To create an array drawer, I will first create the variable, then create a new texture array GUI drawer object in the onEnable function. Here, we need to input our two material properties that we created in the shader, the total number of textures in the array, as well as a file name for the texture array. The file name for an array is not the full path, but only a file name that will override the default name and does not need to be assigned. The output texture array will be stored in a folder alongside the material that I will show you once we have created the GUI. To get the material properties, we will use the findProperty function, inputting our property name and the properties object passed through onGUI. The property name is not the same assigned in the shader graph, but it's a reference that you can find alongside it in the shader graph. Since I am only using 2 textures for this example, for the texture count I will input 2. Now we can use the array drawer anywhere we like. Since the textures I am using do not require extra fields, I will just be using the drawTextures function that will draw all the textures in an array to the GUI. This can also be replaced with individual drawTexture functions that will draw each texture individually by its index. You can also draw textures alongside other fields such as color values or sliders that can be used for other functions. By default, these functions use the layout, but custom recs can be assigned. Note that you are not only limited to using one array drawer, but you can create a new one for each array that you have in a single material. Now that we have created the GUI, we can save it and go back to the editor. As you can see, the material still has the default inspector, so we need to assign ours. In the shader graph, navigate to the graph settings, then down to the custom editor GUI field. Here, since I named the class Custom GUI example, I will insert that here. If your class is inside a namespace, be sure to include the whole path with the namespace, then the class name. Now if we save the shader graph, we can go to the material and see our custom GUI. Assigning textures here will update them in the array and shader, so they can be used just like any other texture, and we can see that here with our custom material in the scene view. The array used with the texture array GUI drawer is created and handled in a folder alongside your material that you can see here. Once the array is created, it can be moved to anywhere and still will be accessed fine, but if your array is deleted for any reason, it will be recreated in the original folder. The folder will store all the arrays for a specific material. Now that the material is created, you can use it for whatever you like and the texture array will handle itself. And that's all you need to know for this asset. Thank you for considering my tool and I hope it improves your workflow with texture arrays.